Flip the model over and it falls right off. This is a result of early contact in the line angle. Our next topic is the inner design of a crown. You may know that cement gaps use die spacers to give cement thickness. Here, we'll explain cement gaps that consider the characteristics of the milling method. I've been experimenting with cement gaps. First, let's see what happens if we give a uniform cement gap when designing the inner surface. I tried giving a constant cement gap of 50 micrometers. On the left is the design file. I chose the coping type to avoid pinching errors with adjacent surfaces. On the right is a photo of the machined result adapted to the model. The right side was scanned and compared to the design file on the left. The fact that this is from an old lecture and did not use Medit software does not matter. Ways to verify the machining results with Medit software will be explained in the next lecture. On the left is the 50 micrometers resolution. The dark red color represents the error region beyond 50 micrometers. These are concentrated in the line angle area. This crown will eventually have premature contact at the line angle and will not go in all the way. The photo on the right shows the result of a crown that retracts 70 micrometers less. The sharper the angle of the line angle, the higher the machining error. Therefore, it's necessary to round the line angles. This is my favorite dedicated burr for rounding line angles. Round off the line angle. It helps to use a dedicated burr. Think of a 0.5 mm curvature corresponding to a radius of 1 mm for a zirconia tool diameter. Keep in mind that over-rounding can be detrimental to retention. Rounding line angles does not eliminate all machining errors. First, let's look at the machining errors that can be calculated. When a plane is machined equidistant with a rounded tool, it leaves a wavy area like the image. The height portion of this error is called the scallop height. The scallop height that would have resulted from machining at 0.1 mm constant spacing using a 1 mm round burr is calculated to be 2 micrometers. I'll skip the detailed calculations because I don't think you'll want to know. What's important is that 2 micrometers is a significant difference from the 60 micrometers error seen at the line angle identified earlier. This can be explained by the different areas that are machined and left behind in flat and curved machining. Figure 2 is an enlargement of the rectangular part in Figure 1. Figure 3 is the residual area after machining a relatively straight part. Figure 4 shows the machining residue of a deeply curved area, colored in red. The second was to give the line angles an additional cement gap corresponding to the machining error. The machining error of the line angle can be reduced, but not eliminated. So, I tried machining with a cement gap of 60 micrometers for the line angle and 30 micrometers for the rest, which is less than the 50 micrometers I gave in the previous experiment. This value reflects the machining error identified in the machining error validation and can vary from machine to machine. You should watch this with the understanding that your machine may differ from mine. I purchased my equipment after going through this verification myself. I'd like to say that machining precision is prioritized over machining speed and the price of the equipment. I'd also like to add that you shouldn't only look at the data from the equipment company, but check it yourself before buying it. We'll talk more about this next time. These photos validate the machining results. The photo on the left shows the scan data of a crown that was machined with an additional cement gap in the line angles, compared with a redesigned file with a uniform 30 micrometers cement gap. The result shows that a uniform cement gap was achieved. The photo on the right shows the machined crown positioned on the model, and a comparison between the scanned file and the design file shows a vertical error of about 10 micrometers. It went in all the way. It may be difficult to understand, so let me explain again. When machining the inner surface, additional machining errors will occur at the line angles. When designing the inner surface, give the line angles an additional cement gap equal to this number. The different machining errors result in a uniform inner offset. Let's demonstrate the retention power of the crowns created in experiments 1 and 2. Position the first crown and press it down well. Flip the model over and it falls right off. This is a result of early contact in the line angle and a relatively large space in the inner surface. Place the second crown, apply good pressure, and flip the model over. It has a uniform internal fit, resulting in a good retention. Here is a paper that shows why a uniform and thin cement gap is important. This paper shows that resin cement thickness affects zirconia's shear bond strength. It is a result of uniform actual cement thickness between planes, not crowns. Resin cements were applied at 50, 80, 160, and 240 micrometers intervals to check the shear bond strength. We can conclude that the thinner the thickness, the higher the bond strength. If so, we can conclude that if we get a uniform and thin inner fit, we can bond thinner zirconia stronger and make it less brittle. As a result, we'll be able to do less occlusal surface removal. Let me give you a case example of another advantage of a uniform cement gap. This is a patient who came to me for root canal treatment with a zirconia crown in tooth number 27 from another dental clinic. The dentist who did the crown was a well-known prosthodontist, and the patient was also a dentist. I replaced the crown, and it's been about 3 years now, and she hasn't had a root canal since. What did I pay attention to when making the crown? As the astute among you may already know, I addressed the hypersensitive symptoms by simply placing uniform, thin cement spacings on the inside of the crown. This phenomenon is explained by the increased stress on the tooth due to polymerization shrinkage as the resin adhesive thickness increases. We can conclude by saying that the cement gap should reflect the machining errors when designing the inner surface of a crown. This will result in a uniform and thin cement gap.